Good morning. I'm David Erdos with Erdos Miller, and I'm going to be presenting on next generation active magnetic ranging with two case studies. So this work was done in conjunction with Gunner Energy Services and Ever. And so first I'll start off by asking, why is magnetic ranging useful or important? Well, with traditional wellbore navigation, as depth increases, so does uncertainty. So at the end of a long lateral, you might have a horizontal uncertainty of hundreds of feet, and your vertical uncertainty might be 10, 50, even 100 feet. And so if you're trying to hit a very small target, namely another wellbore, that uncertainty is simply not going to happen. You're not going to hit it. And so what are applications of magnetic ranging? Magnetic ranging is often used in relief wells. If there's a blowout, you typically need to drill a relief well. You need to follow down the original wellbore and then intercept it at depth. There's other applications that are not blowouts that are also relief wells, like plug-in abandonment, or if you have an old wellbore with an obstruction in it, you can't get back in, or leaking well, that sort of thing. SAC-D is another application. Advanced geothermal systems, and collision avoidance, that's a relatively common one. If you have tight surface spacing, you're trying to maintain separation between your surface holes, you can use magnetic ranging to ensure you don't collide. And there's many more. And so I'll be going over two case studies. The first one is a geothermal application with a rotating magnet system, and then an axis-independent active magnetic ranging system case study that we did in Australia. So how is active magnetic ranging done currently? Currently, the majority of active magnetic ranging is done with wireline. And the way that works is when you want to take a ranging measurement, you have to trip out the entire BHA, wireline in your sensor, and then take your ranging measurement, wireline back out, BHA back in. Depending on hole conditions, depth, that can take 24 or even 48 hours. And if you're on an offshore blowout, your rig spread is $600,000 a day, and you're spending 15 days tripping pipe, that adds up real quick. And there's also other risks with wireline ranging listed here. So what's the solution to this? The solution is ranging well drilling. And so what we did with the ranging well drilling system is that we took the sensors and the processing that's currently done on the surface, and we put it all downhole. So we have very sensitive magnetometers, and we have the computation capability to perform the ranging calculations downhole and then send the answer to surface over telemetry. So the first case study here was done with Ever in southern Germany. They're drilling a closed geothermal loop there, and you can see here there's two rigs drilling in parallel. There's two motherboards that then fan out into 12 lateral pairs. And so you have these lateral pairs, and you have to maintain separation of 65 meters and then intercept at the toe. And without magnetic ranging, that would be practically impossible. And so they started off on this project using wireline ranging. So they had a rotating magnet sub in one BHA, and then they had a wireline sensor that was conveyed in the other BHA. And so they would rotate the BHA in the upper wellbore, creating a rotating magnetic field that the wireline sensor would then record, send to surface over the wireline, and then the measurements would be processed on surface and actioned. And so what we developed was a system that could take these measurements, store them in memory, do all the downhole computations of the ranging measurements, and then send the answers to surface over mud pulse telemetry. And so what this did is it cut down the time to perform a ranging shot from 16 hours down to minutes. And so they were able to take ranging measurements much more frequently and with significant time and cost savings. And so this intercept was achieved successfully on the first attempt with an instantaneous hydraulic communication. You can see the steam coming out of one of the rigs here on the right. And so that was that on the geothermal one. So now I'll talk about the axis-independent, active magnetic ranging, passive magnetic ranging, gyro well drilling system. I know that's a mouthful, but there's a lot of technology packed into this 20-foot long MWD system, or ranging well drilling system, I should say. So here's a picture kind of showing what the situation was. So there was a leaking well that had an obstruction in the wellbore, so they couldn't get back in and plug it properly. And so the regulators required that they drill a relief well and re-abandon the well. And so with this system, the full capabilities are really realized when you use the wired pipe, which is pictured here on the right. And that's technology made out of Norway by Realwell. And so they have a copper braid that gets epoxied onto the inside of the drill pipe. And so with that, you're able to inject current into the formation and then measure the magnetic field created by the current flowing on the target well with the magnetic sensors, perform your ranging calculations, and send the answer to surface. Now, in this case in Australia, wired pipe wasn't available, so we used wireline injection. But since then in North Dakota, we've actually completed a job with the wired pipe, and it worked exceptionally well. So here's some pictures of the cuttings coming up from the milling operation. So we achieved successful intercept on this. It was 8 days from the first ranging run to the last ranging run, and the abandonment was successfully approved by the operator with significant cost savings to the customer, and the whole operation came in well under AFE. And so our mission here is to eliminate wireline ranging runs. This graph on the right shows the time to drill a relief well, with the red line showing traditional wireline ranging techniques. The horizontal axis, I know is small, but that's days, and the vertical axis is depth, and the green is the ranging well drilling system. So the ranging well drilling system can drill a relief well in a third of the time, and it's also a lot safer. You don't have to be tripping as much pipe in and out. That can get dangerous, and the cost savings in a blowout, for example, an offshore blowout where you're getting penalties and fines by regulators and the government, the cost savings of this system can add up to tens of millions or more. And so why is this important? Well, obviously, relief wells, in the case of a blowout, are important for the regulators, the operators, and the environment. And just a single shot went to MWD, so we think wireline ranging must go to ranging well drilling. And so we're actually having operators come to us finding applications for this technology on wells that they were previously too expensive to plug with wireline ranging because of all the time spent tripping, that are now feasible with this ranging well drilling technology due to the significant cost and time savings to the operators. Thank you.